Okay, so this will be a really quick video, but I want to show something I'm kind of proud of. This is a little widget that I've made that helps us understand or plot the time that functions take to execute and get a general graph, a chart that shows us a trend. So there's only 7 of them in here, and we're going to focus on the first 2. Add up to first. I had to give them unique names before they were both called add up to, but add up to first uses the loop. Add up to second uses that little shortcut. Let me see if is that big enough to see. And so we select one of them. Then I can specify a value for n and hit plot and then change n. And what I'll do is increase n, and we'll see some sort of chart that shows what happens as n grows larger. And this is basically just done with a timer in the background. So I click plot, it starts a timer, it does the operation, stops a timer, and then plots it. And then we do it again, and it connects the dots and builds a little graph. So what I want to show you is that if we take this first one, add up to second, which was the one that was faster, we already know it's faster. But what we talked about in the last video is that there are 3 operations, 3 things that take time. Let's think about it that way. This other one, there's a lot of things that take time, but there's 3, and there's always 3 things that take time, no matter what n is, if it's 10 or a billion. So I'm going to plug in a number for n, like 100, and I'm going to hit plot. And it's going to time it. So what it's plotting for us here is not the number of operations, because that's always 3. It's plotting the time. Okay, so we only have one value, so it doesn't really mean much. Let's add in 1,000. There we go. Let's add in 10,000. Okay, so it does seem like this is an extreme slope all of a sudden, but just hang in there because we pop back up. And if we look at the difference here, it's a matter of, what are we talking about? Is these, I can't remember if these are nanoseconds, what that little symbol means. It's a very small fraction of a second. So it looks like this chart is all over the place, and it is on such a small scale. But what I want to show you is that we don't really care about that. We care about a general trend. And when we switch over to add up to first, I'm going to do the same thing, but I'm going to start again with 100. So we're going to add up the first 100. And remember that in this case, unlike add up to second, where it was a constant number of operations, and add up to first, the number of operations depends on n because of this loop. So if we start with 100, okay, you can already see that it's definitely slower. Let's go to 1,000. All right, definitely looks slower again. 10,000. Keep going here. Keep adding in. I'm going to keep going so that we can get a generalized trend. Okay, and that last one took a little bit, and the next one will take a couple seconds, so I'm not going to do it. But what we can see here is that there's a pretty good line that's pretty easy to follow. And as n grows larger, which is down here, the time grows in proportion, which we kind of discussed in the last video, although we were talking about the number of operations. But this is actually time being printed here. And you can see that it follows what we were talking about. It's not perfect, but overall, it's pretty close. And same thing down here, where we said that for add up to second, it's always 3 operations. It's the same number of operations, no matter what n is. So the time is pretty constant. It fluctuated, as you saw when we were working on such a small scale. It did go up and down. But overall, when we're comparing the two, this is significantly better. And if I run this last one here, I mean, take a look at that. As n grows, the time doesn't really change. Now, if we zoomed in, it would be slightly different, but it doesn't matter because this is a massive difference, 1.2 seconds versus a couple of milliseconds. So we'll be revisiting this tool to talk about some of these others as we go. But here are our first 2 generalized trends where we're comparing 2 algorithms that do the same thing. And you can see that they have vastly different big picture overviews of their performance.